Hello, Coach Travis here with another calculus video. So what we got here is we got a derivative problem. We're supposed to find the derivative of this function right here and then evaluate the derivative at the value x equals 8. So alright, so how do I find the derivative of this thing? I look at this and the first thing I should probably think is quotient rule, because I see there's a function divided by another function. So this is a job for the quotient rule. So right here I've got the quotient rule written down, at least how I remember it, that the derivative of a quotient is the derivative of the top times the bottom, and then subtract the top function times the derivative of the bottom, and then all divided by the bottom squared. So that's our quotient rule. So alright, so I just need to look at my function and identify what the top function is and what the bottom function is. And so looking at that function, I can see that 9 times 5 to the x is the top function. And I can see that x to the 5th is the bottom function. And now, if I look at the quotient rule requires me to find the derivative of the top and the derivative of the bottom. So, alright, so that's what I'm going to do here. The derivative of x to the 5th is 5x to the 4th. So this is just the way I organize my work when I'm doing the quotient rule. You don't have to organize your work this way, but I think it's a good way. And then now I have to find the derivative of the top function. And so the constant 9 is a constant multiple. So the constant multiple rule says the 9 can just stay there. And then the derivative of x to the 5th, sorry, I said the wrong thing. The derivative of 5 to the x. So this is an exponential function. And so the derivative of an exponential function is just equal to the exponential function, almost. But then you have to multiply by the natural log of the base of the exponential function. So that's the exponential function rule, shortcut rule for derivatives. So whenever you want to find the derivative of something to the x power, the derivative is just something to the x power times the natural log of the something. So alright, so we now know the top and the derivative of the top, and we know the bottom and the derivative of the bottom. So we have all the ingredients we need to fill out our quotient rule. So the quotient rule says that we start with the derivative of the top. Oh yeah, and the way I do this usually is I draw diagonals, because that's essentially what the quotient rule is saying, right? It's saying you do this is the derivative of the top, and it gets multiplied by the bottom, and then you have to subtract the top multiplied by the derivative of the bottom. So alright, so the top function is, the derivative of the top. The derivative of the top is 9 times 5 to the x times the natural log of 5. And you might say, wait, what happened to the parentheses? Well, if you look at this, everything here is being multiplied, so it doesn't really, the parentheses aren't doing anything. So I just went ahead and left those parentheses out. But I will put parentheses here to separate the top from the bottom. And then we have to multiply by the bottom left alone. And the bottom left alone is x to the 5th. And then now we subtract the top function, which is 9 times 5 to the x. And then that gets multiplied by the derivative of the bottom. And the derivative of the bottom is 5x to the 4th. And then everything is going to get divided by the bottom squared. Oops. The bottom squared. Okay, so the bottom is x to the 5th. So it'll be x to the 5th squared. All right, so that's the derivative. And now if we look at the problem says that we want to find the derivative when x is equal to 8. So basically, just everywhere I see an x here, I can replace it by an 8. But actually, before I do that, I think that maybe I'm going to simplify this. I want to see if I can simplify this a little bit, because it's kind of messy. But let's look at what we got here. We have a 9 times 5x in this. So I look at this and I see two pieces. I see this piece and I see this piece. And in the first piece, there's a 9 times 5x. And in the second piece, there's a 9 times 5x. So I think I could factor that out. And similarly, let's see. Well, there's x to the 4th in this piece, and well, there's x to the 5th in this piece. So I could factor out at least an x to the 4th. So I think we can do that, or I know we can do that. And so let's do it. So all right, so we can factor out, we said we could factor out the 9, and we could factor out a 5 to the x. And then the other thing we said we could factor out was we could factor out an x to the 4th. Because there's x to the 4th here, and there's at least x to the 4th here. Okay, and then let's see, then what's left? Well, what's left in the first one is going to be a natural log of 5. And I only factored out 4 of the x's, but there are 5 x's there. So that means we have another x. So there'll still be an x left. And then we have to subtract, and let's see, what, oh, we factored everything out here except the 5. So it'll just be minus 5. So that's somewhat simpler. And then the bottom, x to the 5th squared, that's x to the 10th. Oh, and that's nice now, because now we have an x to the 4th here, and an x to the 10th here, and so you can do a little bit of simplification there. These 4 x's will knock out 4 of those x's. So I'm going to go ahead and just erase here. So this x to the 4th is just going to go away, or turn into 1. And this x to the 10th will turn into an x to the 6th. Okay, and now I think we're pretty much as simple as we can be. And you might say, now don't do the wrong thing here. You can't cancel these x's, because remember, you can only cancel factors. And since there's no x here, we can't factor the x out of the parentheses. And so it's not legal to cancel that x. You can only cancel things when you can factor them out. So that's an easy mistake to make. So try to avoid that mistake. Okay, now let's finish this thing up here. So now basically everywhere I see an x, I replace it by an 8. So my final answer is going to be like, it's not going to be a very nice number. So my final answer is going to be 9 times 5 to the 8th, and that's an enormous number, and then multiplied by the natural log of 5 times 8, and then minus 5, and then all of that gets divided by 8 to the 6th, which again is a very large number. But that's, I would say, I would call that pretty much my final answer right there.